Hello, and welcome to multiplying and dividing rational expressions. Now, normally, when we learn a new type of mathematical object, right, so a rational expression, we first learn to work with it, some domain, and then we'll add and subtract, and then we'll multiply and divide, and then we'll do other things. But it turns out in rational expressions, multiplying and dividing is easier than adding and subtracting. So generally, multiplication and division comes first in the order that we teach it. Okay, so in order to multiply rational expressions, first we're going to, this is going to sound familiar, factor the numerator and denominator of each fraction if possible. Then we'll divide out any common factors, rewrite as a single fraction, and then leave in factored form. Now, these two steps, 2 and 3, are sometimes switched. It doesn't matter the order. I generally divide before I rewrite as a single fraction. Just as long as I take something from the numerator and something from the denominator, it's all the same. I just don't want to get caught up in writing it too many times, is really what it comes down to. I'm kind of lazy. So, here's what I'm going to do for number 1. I'm looking at 40 as 5 times 8. I'm looking at 6 as 2 times 3. I'm looking at 15 as 3 times 5. And I'm looking at 5 as 5, right? And I'm going to leave the x cubes, the y, I'm going to leave those as they are. So I'm going to rewrite this as 5 times 8, x to the third, over 2 times 3y, and I'll multiply that by 3 times 5, y squared, over 5x to the fifth. Now, I encourage you to use different colors on this, or a highlighter or something, so that you can kind of still see what's going on beforehand, or else it gets a little bit messy. So here's how I go about my canceling. So I have a 5 in the numerator. I look for a 5 in the denominator. All right, it cancels. Remember, 1 5 in the numerator cancels 1 5 in the denominator. 8. Well, I don't see an 8 in the denominator, but notice this 8, 2 goes into 8 4 times. So I can simplify the 8 and the 2. The next number, I'm going to skip that x cubed for now. 3 in the numerator. Do I have a 3 in the denominator? Yes, I do. That cancels. 5. Do I have another 5? I do not. So just by canceling the numbers, I now have 4 times 5. I almost forgot that 4. Excuse me, that one caught me by surprise. Didn't have a chance to mute. All right, so I'll have 4 times 5, x cubed y squared, divided by y times x to the fifth. Now, we simplify our variable portions just using rules of exponents. So 4 times 5 will be 20. I see that I have x to the third in the numerator and x to the fifth in the denominator. X to the fifth is larger, so I know that the leftovers will be in the denominator. And 3 and 5 are different by 2, so I'll have x squared in my denominator. Looking at the y variables, I have y squared in the numerator. That's 2 of them. I have 1y in the denominator, so there are more in the numerator, so that's where they will end up. 2 minus 1 leaves me with 1, and I have multiplied my rational expression. You'll notice that we didn't multiply anything. I guess we wrote them next to each other here, which is the multiplication step. But there's not a whole lot of multiplying when it comes to multiplying rational expressions. Okay. Number 2, a plus 5 over a minus 2 times a minus 3 over a plus 4. Sometimes you get those problems that are already factored and nothing cancels. If nothing cancels, we multiply them, which, by the way, you don't even have to multiply. You could leave them in factored form. It's completely correct on most online homework systems, but if you're not my student, you should check with your instructor to see if they want you to multiply that out. Okay, so sometimes that's the easy case there. We hope for those ones. Now, number 3, completely factored numerator and denominators, both fractions, we want to multiply. So I start here with h plus 2 in my numerator, and I look for an h plus 2 in the denominator. There is none. So I move on to the next one. All right, I check that. H minus 8. Oh, there's an h minus 8. I could cancel those. H minus 6. Oh, there's an h minus 6. I can cancel those. H plus 3. No h plus 3 in the denominator. Now that I've checked everything in the numerator, I don't have to go back and check everything in the denominator because there's nothing from the numerator it can cancel with. So this answer will be my h plus 2 times h plus 3 all over h minus 2 times h minus 7. And remember again, those h's don't cancel because they're encumbered with addition and subtraction. So we can't cancel the h's and deal with the numbers. They have to be written as factors before we can cancel them out. And factors involve multiplication and, in a loose translation, division. All right. Now, you know that I'm not going to give you homework. There's a whole bunch of things that are already factored, and you just have to write things down. We're going to have to factor some things. So let's try this one. Okay, I'm going to break this down into a first numerator. So we're going to take n squared plus 6n plus 8. We're going to factor that. In order to get n squared, we're going to multiply n times n. And let's try that again. In order to multiply to get plus 8, first is positive, so these are the same sign. Because the 6 is positive, these are both positive. Now what multiplies to be 8 adds to be 6, 4 and 2, first things that come to mind. I'm going to complete our numerator. I'm going to factor my second numerator. Remember, first it takes you by surprise. There's only 2 terms. What do? Oh no, but it's the difference of squares. Remember, 1 is always a perfect square. This factors this n plus 1 times n minus 1. Now let's look at our denominators. N squared plus 3n plus 2. Let's write down what we have first here. N plus 4, n plus 2, and n plus 1, n minus 1. Make sure I get everything in the right places. That's kind of a concern when I do my factoring like this too. To get n squared, I'll multiply n times n. To multiply to get plus 2, I'm going to multiply 2 numbers that are the same sign. This tells me that they're both positive. Multiply to be 2, add to be 3, n plus 2 and n plus 1. And my last denominator, let me write this one in here too. N plus 2, n plus 1. Now, I only have one denominator remaining, which is kind of nice because sometimes I'll leave one for last. And if you watched my simplifying rational expressions video, keep in mind we can use what's already factored to kind of help us figure out how to factor this last one if we need to. This one doesn't look like it's too much of a nightmare, but trust me, there's one coming. N squared plus 8n plus 16. To multiply to get n squared, we're going to multiply n times n. To multiply to get 16, a positive 16, we'll multiply 2 numbers of the same sign. The 8 being positive tells me these are both positive. Multiply to be 16, add to be 8. That's a pair of 4s. All right, everything's factored, which admittedly, it's the most challenging step when it comes to multiplying or dividing or simplifying rational expressions. All right, so I have an n plus 4. I have another n plus 4, so I'm going to cancel one of them. N plus 2 in the numerator, n plus 2 in the denominator. n plus 1 in the numerator, n plus 1 in the denominator, n minus 1 in the numerator, no n minus 1. So it doesn't cancel all of that. And I get n minus 1 over n plus 4. But think about this. Why is this skill useful? I'm asking you to evaluate this when n equals negative 10. That's a lot of work. But if you can multiply that out and get it simplified here, when n equals 10, 10 minus 1 is 9, 10 plus 4 is 14, that's 9/14. That's something we can evaluate just by looking at it. So this really is a valuable skill for some of the things that you'll do in later math classes. All right, so this is definitely a later math class thing that we'll use most of our techniques for. All right, now let's divide rational expressions. To divide rational expressions, we're going to multiply by the reciprocal of the second fraction. Here's our little reminder. If I want to divide a half into 3/4, what I'm really doing is this complex fraction. I don't want to have a fraction with another fraction. So I'm going to multiply by a fraction that is equivalent to 1, right? 4/3 over 4/3 is 1. But I multiply by exactly the right thing so that my denominator is now 1, right? It's the reciprocal. 3 times 4 is 12, 4 times 3 is 12, 12 over 12 is 1. And what I've done is I've turned this numerator into a multiplication problem. What did I do? Instead of 1/2 divided by 3/4, I've now written it as 1/2 times 4/3. That's why we multiply by the reciprocal of the second term. It's the divisor. So my first step in this problem will be to rewrite it as multiplication. And then I can simplify. That 8 and the 4 simplify a little bit for me. I'm going to write it like this. 4 goes into 4 one time. 4 goes into 8 twice. So we now have 2 times 7 is 14 over 15 times 1. 14/15. All right, so dividing really just has one extra step. We're going to, instead of calling it division, we're going to multiply by the reciprocal and then do the exactly the same thing that we did to multiply. All right, so the instructions are exactly the same. All right, here we go. First step, leave our dividend, change division to multiplication, and then switch the order. Take the reciprocal of the second term. All right, take the reciprocal. Now, if it helps, and this is why a lot of people will write these into a single fraction first, because when you multiply them, the parentheses come naturally. All right, I want all of d minus 5 multiplied by all of d plus 3. So switching those two steps that I mentioned earlier sometimes are helpful to make sure that you can factor things. Once I have it written like this, I have a d plus 3 in the numerator and in the denominator. And it looks like that's all that simplifies, or excuse me, cancels. D plus 8 over d minus 5. Remember, the d's do not cancel because they're not written as multiplication. They have to be written as multiplication before you could cancel them at all. That took less space than I expected. So I'm going to move this one up a little bit because I have a feeling we're going to need some room. Oh, this is our last problem. Good, we have plenty of room. Okay, so let's start by factoring. And when I'm looking at all of this, I'm thinking this is easier to factor. Because it has an x squared. 6, the 18, I'll get to this one next. Okay, x squared plus 2x minus 35. That'll be x times x to get x squared. To multiply to get negative 35, one's positive, one's negative. Multiply to get 35, different by 2. The only way I could think of, other than 1 times 35 to get 35, is if I have 7 and 5. Because the 2 is positive, the bigger number 7 is also positive. So I'm going to rewrite this a little bit here. I'm going to leave that first numerator blank because I didn't want to. That's really what it comes down to. I didn't want to factor that. Change the division to multiplication. I take my x squared plus 10x plus 21. That'll be x times x to get x squared. A positive 21 means that these two numbers are the same sign. The positive 10 tells me they're both plus. Multiply to be 21, add to be 10. 7 and 3 work out really well. But remember, this denominator moves to my numerator. As soon as I flip that division to multiplication, I flip that denominator, take that reciprocal, and put it in the numerator. Now I'm left with these two. Which one do I want to factor next? I want to factor 6x squared plus 13x minus 15. It's not that I want to, but I'm going to. So we have 6 times a negative 15. That's feeling like 90, right? 15, 30, 45, 60, 75, 90. So we have a negative 90 is what they multiply to be. And they're going to add to be 13. I know because the 90 is negative, they're going to have opposite signs. Because the 13 is positive, the bigger one will be positive. So I'm going to start here. Negative 6 and 15. Those are different by 9. So I need this to be a little bit bigger. I'm going to bring my negative number down a little bit. 5. 90 divided by 5. Let's turn on our calculator here. It's 18. Oh, look at that. Negative 5 and 18. That's a difference of 13. Fantastic. So the 6x squared plus 13x minus 15, I'm going to do this the long way. I'm going to write down all the steps. I'm going to rewrite 6x squared plus 13x minus 15 as 6x squared minus 5x plus 18x minus 15. These first two only have an x in common. These second two seem to have a 3 in common, and when I factor out a positive 3, I'm left with 6x minus 5. So this is 6x minus 5 times x plus 3. Now I find this polynomial. It was in my original second numerator, which means now the factored version goes in my denominator. All right. Now, this last one, and I'm going to put it in blue. And we're going to use all our paper for this probably. Our digital paper. Okay. 18x squared plus 9x minus 20. Here's the deal. I could do the same stuff, right? 18 times negative 20. Multiply, add, I could do all that. But what I'm thinking is this. I'm going to cancel stuff, right? I know that I'm going to have cancellation going on. So 18x squared, doesn't it seem like it should have a 6x minus 5? This is just a guess. And if that's a 6x minus 5, I could figure out what this part has to be, and then I'll check it, right? I could always go forward and use the same factoring techniques, factoring skills. And if you want to just stop listening right now, right, just hit mute until I write the answer up in here while you factor it correctly. That's cool. But I'm going to show you my guess and check method as well. I'm going to guess that it's 6x minus 5 because there's one in the denominator, 18, 6x. It just seems reasonable. So what do I multiply 6x by to get 18x squared? That's going to be a 3x. What do I multiply negative 5 by to get negative 20. That'll be a plus 4. And now we check. That's why it's called guess and check. 6x times 3x is 18x squared. 6x times 4 is plus 24x. Minus 5 times 3x is minus 15x. And negative 5 times 4 is negative 20. 24 minus 15 is plus 9x minus 20. All right, it works out. So sometimes you can use these ones that are a little bit easier to factor in order to factor the ones that look more difficult. And that's why I always save those for last. All right, so now we've factored every numerator, every denominator completely. We've switched our division into multiplication by the reciprocal. And now we check. 6x minus 5 in the numerator, but we already know there's one in the denominator. We used it. 3x plus 4. There is no 3x plus 4 in the denominator. X plus 7. Oh, there's one in the denominator. And x plus 3 has a match in the denominator. And we now have our answer. 3x plus 4 over x minus 5. And again, think about it. If I asked you to evaluate this when x was negative 17, oh my goodness, how hard would that be? So much easier if you're able to simplify. Okay, that is it for multiplying and dividing rational expressions. It's just really one extra step on top of simplifying rational expressions. You've got this. Thanks for listening.